All right, boys and girls, today we're going over Unit 9, Lesson 4. Make sure your name is at the top of the lesson, and let's begin. As we look at the do now for Part A, it says, find to the nearest tenth of a foot the height of the tree represented in the accompanying diagram. So I always like to underline the question. I have to find to the nearest tenth of a foot the height of the tree. So I can see that this would be the height of the tree, this segment right here, which is X. So I'm just going to circle X just because I know that's the goal of the question here. Well, what do I know about trees with the ground? Well, just like when you go to the doctor and they take your height, you don't stand to the side, you don't lean, right? You stand straight up and down with the ground. So does a tree, straight up and down with the ground. That's perpendicular. So that means there's a right angle being formed here. So I'm just going to add that on. So now that I know I'm actually dealing with a right triangle, and I can see that one of the angle measures that they gave me was 62, I'm thinking I'm going to use SOHCAHTOA here, that trigonometry, to try and solve for that missing height. Because anytime I don't know the missing side of a right triangle, we'll use Pythagorean theorem. But that means I'd have to know at least the leg and the hypotenuse, and I don't. So since I can't use Pythagorean theorem, like I said, I'm going to use trigonometry. So at the top of my paper, I'm just going to write SOHCAHTOA. All right. So again, I'm looking for X, which is the height. They also gave me 15 at the bottom, right? This is my smaller leg. That's my base. So now I have to ask myself, X is right across from 62. So that means it's opposite 62. This would be my opposite side. 15 is right next to 62. Right next to means adjacent. So 15 would be my adjacent side. Again, I know that directly across from the right angle would be my hypotenuse, and that's not what I'm looking for, but I also know that this is not a side that I would be using in this question because it's not labeled in any way. All right, so I know I'm using opposite and adjacent. If I look over here, I can see O and A. There it is. I got to use tan. So I'm going to set up tan of 62. Really, that's tangent of 62 degrees. And that's going to equal my opposite over my adjacent side. I just like to set myself up so I know I don't make any mistakes. The opposite side was X. I'm going to throw that up top. My adjacent side was 15. I'm going to throw that in the bottom here. And then I'm ready to go. I'm just going to start solving here. So if I have a fraction on the right-hand side, I want to make this a fraction on the left-hand side by putting it over 1. And now I'm going to cross multiply because I have a proportion. I'm going to do X times 1. I'm also going to do 15 times tan 62. All right, X times 1 is X. In the calculator, when you type in 15 times tan 62, you end up getting a decimal, all right? Make sure you are in degree mode before you type that in, all right? Or else you're gonna get the wrong answer. So when I type it in, I get 28.21, blah, 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 right? A big decimal here. But if I look back at the question, it says I want to round to the nearest tenth. Well, there's 1 0 in 10, so I want to go one place after the decimal. So now I got to ask myself, is that 1 telling the 2 to round up or just chill, hang out? Well, 5 or above, give it a shove. He ain't 5 or above, so he ain't getting no shove. So I know that 28.2 feet would be my final answer here for Part A. All right, Part B. Why can't I use Pythagorean theorem? I actually said it before. Hopefully you guys remember. So as I look here, if I want to use Pythagorean theorem, I'd have to know at least 2 of the sides to plug in because I could only look for one missing side at a time. That means if I try to use Pythagorean theorem right now, I would be looking for 2 missing sides, and that's not going to work for me. All right, so here we go. There is not enough information. You can only find one missing side at a time. All right, cool. Moving on to the guided practice down below. Whoop. All right, here we go. The bus drops you off at the corner of H Street and First Street. Okay, the corner of H Street and 1st Street. So that would be this 90-degree angle right over here, that corner, okay? Approximately 300 feet from the school. And again, here's the school. Here you are. Let me draw us. Here we are. Yay! The bus drops you off here. Here's the school. You're 300 feet away. You plan to walk to your friend Janeth's house after school to work on a project. Approximately how many feet are you going to have to walk from school to Janeth's house? Round your answer to the nearest 10th. So you know me, I always like to underline my question. So it says, how many feet will you have to walk from the school to Janeth's house? So I'm going from the school to Janeth's house. So if this is the distance that I'm looking for, this is where I want to place my variable x. Because I don't know what that distance is right now. I want to find it. And then it also says I have to round my answer to the nearest foot. That gives me a hint that I'm probably going to have to round, so I have to be careful. All right. Well, I can see that the angle measure they gave me in this question is 41. All right, so anytime I see an angle, I'm thinking I'm probably using trig, right? SOHCAHTOA. So again, I see I have a right triangle. That means I'm allowed to use trigonometry. Why can't I use Pythagorean theorem? Well, I only know one side, right? The length of one side. I don't know what this leg is going to be, so we can just plug in and get x. So since Pythagorean theorem isn't going to work here, I have to again use trig. I have a right triangle. I'm good to go. One more time. Let's write it out, people. SOHCAHTOA. All right, so here we go on the side. I know that right across from my right angle is my hypotenuse, so I'm looking for x. That means x is my hypotenuse. All right, and again, 41 is the angle they gave me. I can see that 300 is right across from 41. That means it's right opposite 41. All right, so when I look at my SOHCAHTOA here, I need the opposite and the hypotenuse. I can see opposite and hypotenuse would be sine, so that's what I'm doing here. So when I find sine of 41 degrees, it should equal my opposite over my hypotenuse. Well, my opposite side was 300 feet, and my hypotenuse I'm not sure about yet. That's going to be my x. And then it's just like the do now. It's what we've been working on for a few days. Anytime I have a fraction, I want to make the other side a fraction as well. And you can always do that by putting it over 1. And then here we go. We got to cross multiply and solve. So I'm going to do 300 times 1, sine 41 times x. All right, here we go. 300 times 1 is 300. X times sine 41 is x times sine 41. I can't put those bad boys together. Think back to algebra 1 if you're still having trouble with this. Just pretend I'm getting rid of the sine for a minute. It's the same thing as saying what's x times 41? It would be 41x, right? But now I have that sine there, so it's going to be x times sine 41 instead. All right, I'm still trying to get x by itself, so the opposite of multiplying is dividing. So I'm going to divide sine 41 on both sides. Right, sine 41. This is now going to cancel out. All I have left is x equals, and again, before you type this in, make sure that you are in degree mode. So 300 divided by sine 41, when you press enter, you get a decimal, right? 457.2, da 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 da. But I want to round to the nearest foot. So is it going to be 457 feet, 458 feet, right? I have to stop at that ones place, that whole number here. So now I got to ask myself, is 2 telling 7 to round up or chill out? 5 or above, give it a shove. He ain't 5 or above, he ain't getting no shove, so it's going to stay. So 457 feet would have been my answer for this question for the guided practice. Okay. Let's go to the next page. All right. Oh my gosh, I'm all over the place. Okay, here we go. Example 1. It says, when given 2 acute angles in a right triangle, you can choose either one as the reference angle. So all you've seen so far is one reference angle, just like in the do now. In the first question, let me grab that again. In the first question, we had a reference angle of 62. That was it, right? I can't use 90. I got to use one of these acute guys, but I only had one of them, 62. Same thing down below. Well, I had 41, but that was it. I don't know what this angle was to work with, okay? So I had to use 41. Now you can see that they're giving you both reference angles. All right, so you can pick whichever one you want to use. I'm going to find the length of A using 40 and 50, just so you can see that it doesn't matter which reference angle you use, but you do only have to pick one. All right, so I'm going to start off with 40. All right, so I'm going to do 40 in blue, and then I'll do 50 in pink, all right, a different color. So here we go. From 40 degrees, I know that A would be right across. Okay, that would be my opposite side here. All right. And I can see that 26 is right across from the hypotenuse. So I know that 26, it's right across from my right angle. So that makes it the hypotenuse. Hello. All right. Hypotenuse here. So if I want to find the measure of A using 40, I need to think of, well, which trig function uses opposite and hypotenuse? Well, it's probably a good first step if we write them out up top. So, toa. Guys, I've been doing this forever and I still write it every single time. I don't want to make a mistake. All right, here we go. Opposite hypotenuse, that's going to be sine. So here we go. I'm going to find sine of 40 degrees, and I know that sine is opposite over hypotenuse. Well, from 40 degrees, the opposite side was A, and the hypotenuse was 26. All right, so here I go. I got a fraction on the right. I got to make a fraction on the left. Give this bad boy a cross multiply. Okay. A times 1 is A. And then in the calculator, 26 times sine 40 gets you a decimal. All right, it's going to be 16.712, blah, blah, blah. But if I read the directions for part A, I have to round to the nearest hundredth. Okay, so I'm finding A to the nearest hundredth. Let me underline that. Whoop, whoop. There's 2 zeros in 100, so I want to go 1, 2 places after the decimal. All right, that means I want to stop at that 1. So is 2 telling 1 to round up or chill out? He is chilling out, guys. 5 or above, give it a shove. He ain't 5 or above, so it's going to stay. So I know my value of A is 16.71. All right, so that's just one method I could have used to find my value of A. Now instead, I'm going to find A again, but this time I want to use B. 50 as a reference angle. All right, because I want you to see that you're going to get the same answer no matter which one you pick. So here we go. From 50, A is actually now the adjacent side because it's right next to 50. But 26 is still the hypotenuse, all right, because it's still across from that right angle. So here we go. What uses the adjacent side and the hypotenuse? Well, adjacent, hypotenuse, boom, there it is, cosine. All right, here we go. Cosine of 50 degrees. Again, cosine is adjacent over hypotenuse. Well, the adjacent side is A, and my hypotenuse is 26. Again, I have a fraction on the right. I have to make a fraction on the left. Give that baby a cross multiply. Boom, boom. Here we go. A times 1 is A. And 26 times cos 50, when you type that in the calculator, you see it's the exact same decimal. 16.712, blah, blah, blah. All right, and then again, I'm rounding to the nearest hundredth. 100 has 2 zeros in it. I go 2 places after the decimal. And again, this 1 is going to stay, right? 2 is not rounding him up. So I know, again, my value of A is 16.71. So it doesn't matter which angle you pick, just stick with it the rest of the question, all right? So that way you don't get confused. Was this originally the opposite? Now it's the adjacent, you know what I mean? So just pick one angle to work with all the way through, all right? Does anyone know why I'm getting the same answer on both sides? Yeah, I'm getting the same answer on both sides because sine of A equals cos of B, all right? Sine of A equals cos of B. Sine of A equals cos of B. I'm getting the same answer because of this property that we've been going over for days now, all right? And the only reason these guys equal each other is because angle A and angle B are complementary. Boys and girls, you need to have this in your notes if you want to get full credit when you submit this on Canvas, okay? Super, super important. When you guys take the Regents, because I know right now we are still scheduled to take it. By the way, I'm making this video, what is this month? October. So as of right now in October, you're scheduled to take it, but this is huge, okay? They're gonna ask you this on the Regents and you need to know it. That's the only reason those two guys will equal each other, because angle A and angle B, my acute angles here, are complementary. All right, part B. Now it's asking me to find the value of B using a trig ratio. So again, it doesn't matter which one you use. I can use 40 as a reference angle or 50 as a reference angle. I'm gonna just use 40 again, I don't know, I'm just picking it. I don't know why, but I am. So now if I'm using my 40 as a reference angle to find B here, well, B is right next to 40, so this would be my adjacent side, all right? So when I use my reference angle as 40 to find the length of B, I can't use B and A together. I can't say, oh, well, what's my opposite and my adjacent side? Oh, that's tan. Wrong. All right, I can't use tan. Yes, I just found out that A is 16.71. You want to know what the issue with that is, though? That's not an exact number. I had to round to get that answer. Illegal. Do not ever, ever, ever use a rounded answer to find another section to the question. All right? You want to use a whole number that they gave you, okay? Actually, I shouldn't have said that. It doesn't have to be a whole number, but you have to use a value that they gave you, okay? You can't use a rounded number. Illegal. So that's why I'm going to use B, my adjacent side, with the 26. All right? So adjacent and hypotenuse, boop, cosine. Boom. So now I'm going to find cosine of angle 40, because that's the reference angle I'm choosing to use. Cosine is adjacent over hypotenuse. Again, my adjacent side is B. My hypotenuse is still 26. And then I just solve it how we have been. I have a fraction on the right. I got to make a fraction on the left. Throw that baby over 1. Give it a cross multiply. Boom, boom, boom. All right, B times 1 is B. In the calculator, 26 times cos 40, press enter, is 19.917, blah, blah, blah. All right, but I don't want to write that whole thing down because it says again, when I'm finding the value of B, I want to round to the nearest hundredth. I know that in 100, there's 2 zeros, so I want to go 2 places after the decimal. Here we go, 5 or above, give it a shove. He is 5 or above. So he's getting the shove. It's going to be 19.92. All right, so that's going to be my answer for for that length of B. All right, and on the side, if you want to, again, try finding sine of 50, because that's the trig function you would have used if you had 50 as a reference angle. I'm just going to add that to our notes quickly. If you're using 50 as a reference angle, you would have had to have used sine, all right? And you would have had B over 26, cross multiply, you should have got the same thing. B equals 19.917, and then again, when you round, you get that B equals 19.92, all right? Here, I should write this on the side, B equals, okay? Because again, so sorry, if I am using 50 as a reference angle, B is actually opposite. All right, so that would be adjacent and opposite. I'm sorry. Oh my gosh, hypotenuse and opposite, which again would have been the sine function. Okay. All right, let's look at example 2 down below. All right. Example 2 is very similar to what we just worked on in example 1. So I'm going to actually have you guys do this question on your own, and then we'll check back together to see what answers you're getting at the end. All right, at this point, press pause and check back. All right, here is the answer for example 2. So this one, I don't want to say it was simpler, but they only gave you one reference angle, so you had to use 28, all right? So from 28, I know that this was the opposite side because it's right across. This is the adjacent side because it's right next to, and this has to be the hypotenuse because it's right across from that 90-degree angle. Okay. The question gave me a bunch of information up here. It said I'm working with a right triangle, so that means I'm allowed to use Pythagorean theorem or trigonometry. All right, so I had to use trig here, that's SOHCAHTOA. It's asking me to find the measures of IG and IH, those two segments. So when I don't know what something is, I call it a variable. And since these are two different segments, I made them two different variables. I called this guy X and this guy Y. All right. So if I'm solving for X, I had to use the opposite and the adjacent because opposite, I'm looking for X. Adjacent, that's the only number they gave me. All right. So O and A is the tan function. So I'm going to find tan of 28 because that's my reference angle here. I plugged everything in, showing all your work. This is so important, guys. When you turn these lessons in, if you aren't showing all these steps, we're going to send it back, right? You got to show your work. This is what you have to see on the regions. All right, so when you finally round at the end, you should have got 6.5 because, again, just to remind you guys, it says round to the nearest 10th. Make sure you're doing that. 10 is 1 0, one place after the decimal. Now I'm going to go back. I want to find Y. Well, I had to round to find X, so it's illegal for me to use this side, all right, if I want to find Y. So I have to use the 12.2, that adjacent side again. So hypotenuse and adjacent, boom, 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 there it is. That's the cosine function. So I'm finding cosine of 28. I plugged in my variable and my side length, right? You cross multiply, showing all your work, showing the pre-round, and your final answer. I can't tell you how many times us as teachers, when we're grading the regions, kids quickly make like little rounding errors. And because you don't show this step a lot of the time, we can't give you partial credit. You have to get in the habit of showing all your work. How long does it take to write this step? Like 5 seconds. All right, you guys can do this. All right, and that was the answer for example 2. Let's make our way to the last page, to example 3, final question of the day. All right, this was a pretty heavy question, so we're going to go through this one carefully together. It says a shipmate set a boat to sail exactly 27 degrees northeast from the dock. Okay, here we go. After traveling 120 miles, the shipmate realized he had misunderstood the directions. He was supposed to set sail going directly east. How many miles will the shipmate have to travel directly south before he is directly east of the dock? Round your answer to the nearest mile. Wow, that was a lot. Okay, let's break this question down. Here we go, a shipmate. He set a boat to sail exactly 27 degrees northeast from the dock. Okay, here we go. Here's my 27 degrees. Here's the dock. If I want to go northeast, here's north, here's east. So I want to go northeast. So it looks like this would be that northeast side. All right. It says after he travels 120 miles, and that makes sense because here's the 120 miles he traveled northeast, going up and to the right. He realized he misunderstood the directions. He was just supposed to go east. He was just supposed to go east. Yikes. All right, so he really just wanted to go, again, east, just to the right. So he wanted to go in this direction. Yikes. And he went all the way out of the way here. So part A says, how many miles will the shipmate have to travel directly south? I know that south goes straight down. So here he is. He went 120 miles out of the way. Now he's got to go south, straight down. So this is what the question is asking. How many miles will he have to travel directly south? All right, and that's this segment right here, before he can go east. All right, so here we go. I'm seeing an angle measure. I'm seeing it's a right triangle. I'm thinking SOHCAHTOA is good to go here. All right, again, I can't use Pythagorean theorem. I don't have enough information. So here we go. SOHCAHTOA, 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 SOHCAHTOA. I always think of Finding Nemo when I write SOHCAHTOA. That scene when they're in the tank and they're like, oh, what is it? They're trying to like egg Nemo on to go up into the. Okay, yeah, you guys don't know that. Okay, moving on. How many miles will he have to travel directly south? So since this is the segment that I'm looking for, I'm going to label that with the variable x, because this is the line segment I don't know and I need to find it. Here we go, 27. That's the degree measure that they gave me. So here we go. X is right across. It is right opposite that 27. And 120 is the only line segment they gave me. And it's also right across from my right angle, making it the hypotenuse. Everyone goes wild. It's the hypotenuse. Okay. If I'm using the opposite and the hypotenuse, what trig function is that going to be? Boom, 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 whoop, sine. So here I go. I'm going to find sine of 27 degrees, because that's the angle I'm working with here. And I know that sine is opposite over hypotenuse. My opposite is x, the side I don't know. The hypotenuse is 120. It's across from my right angle. Here I go, setting up my proportion, and boom. Cross multiply, cross multiply. X times 1 is x. 120 times sine 27. Let's write that out. 120 times sine of 27 is what you're punching in your calculator, okay? When you type that in, you get 54.4 da-da-da-da-da. All right? But the question says I want to round my answer to the nearest mile. All right, so that means I want to go to the nearest whole number in that ones place. So now I got to think, is 4 going to round his neighbor up? All right, 5 or above, give it a shove. He is not 5 or above, so he ain't getting no shove. So I know that 54 miles would be the answer to part A. Now that I got that answer, I want to plug it back into my diagram here. So I know that X is 54 miles. Boom. All right, and then the second part here says, how many extra miles did the shipmate travel by going the wrong direction compared to going directly east? So again, he went the wrong direction. He had to go northeast, then he had to go south. All right, I'm just color coordinating here. He had to go northeast, that was yellow. Then he had to go south, that was the orange, okay? Compared to going the right direction, which was supposed to just be east, okay? East is the pink. Here he was just supposed to go boom, all right? So you can already tell that he went a lot of miles out of the way. He went up and down when he could have just went boom, right over. We want to figure out how many extra miles that was. Well, I know that in his original trip, which was really the wrong trip, he went 120 plus 54 miles out of the way. So I'm going to just show that on the side here. He went 120 plus 54 miles, okay, before he finally got to that destination spot in the corner. 120, 54, when I add them together, boom, I get 174 miles. Okay, so that's how far he actually traveled. But the question wants to know how much should he have traveled, so we can figure out what those extra miles would be. All right, I have no idea how long he should have traveled, so I'm going to make another variable here. I'm going to call this y, because again, I don't know how long it is, but I know these guys are going to be different numbers, okay? So I'm going to call this y. Here we go again. From 27, y is right next to that reference angle, making it adjacent. So I'm using y because that's the side that I need. That's my adjacent side. And then I also, again, have to use 120, okay, because that's a non-rounded number. I have to use 120. So adjacent and hypotenuse, boom, that's cosine. So here we go. I'm going to now find, cosine of 27 degrees. We know that cosine is adjacent over hypotenuse. All right, my adjacent side was y. My hypotenuse is 120. Make this bad boy fraction. And then here we go. I got to cross multiply. y times 1 is y. 120 times cos 27, I'm going to show that work. 120 times cos 27. When I type this into my calculator all at one time, I get a number of 106.9207 right? There's a bunch of numbers because it's just going to go on forever here. And I have to include all of these, okay? Because even though it says I want to round to the nearest mile, you are not doing that until the very, very, very last step, okay? You never round until you're done with the question. You have your final answer, okay? This is not my final answer, so I am not rounding it. So here we go. I'm going to take how far he actually traveled, which was 174 miles. Boom. I'm going to subtract away 106.92078 because again, that's what he should have traveled, and that will get me my answer of 67.07922. All right. So now that I have figured out how many extra miles he traveled, he went 67 point all this right out of the way. Now I'm going to round to the nearest mile. So the nearest mile would be like the nearest whole number here. All right. So here we go. Boom. If I look at the neighbor, 5 or above, give it a shove. He's literally nothing, so he ain't going nowhere. So my final answer here would be 67 extra miles. How much farther did he travel than he needed to? Well, he went 67 extra miles out of his way. All right, that's a little bit longer than he had to. All right, so as we look here below at the independent practice, make sure you get those 2 questions done. You guys, as always, need to show all of your work, just like I'm doing on all of these questions here. All right, if you have any questions, send us a message in Canvas, and have a great day.